The mean intelligence level of group of students is 90 with standard deviation 20. Assuming intelligence level is normally distributed, find the percentage of students with intelligence level over 100. As in this example is which is a normally distributed having mean. So in solution we first take as a mean here x bar as a 90 and SD sigma as a 20. As this is a normal distribution, so by normal distribution we first evaluate normal variable z as x minus x bar divided by sigma. So we first define x to evaluate the example. As this is a normal distribution, so the value of x is in inequality. As we observe here, we asked over 1000, that means more than asked here over 100, that means we asked more than 100 intelligence level number of students in a percentage. Okay, so we take here as x 100 as it is in inequality, so corresponding 100 we evaluate z, so we take 100 in formula as x minus x bar is a 90 divided by sigma as a 20. So 100 minus 90 is a 10 by 20, so z is here 0.5. So we define normal variable as 0.5. Now first part is completed. Now in second part we define a normal curve always, in which the maximum height between curve and the axis is represented point on curve as average of distribution, which is here 90, and on axis normal variable as a 0. Now as we take variable as a 100 which is more than 90, so it appear on right hand side. Take any point on this curve as x as a 100, and corresponding 100 we get normal variable z as 0.5. By taking perpendicular on a axis we represented 0.5. Now we have asked percentage of students with the intelligence level over 100, that means more than 100, that means we have asked this area which is on right hand side. If we ask less than 100, then the area which appear on left hand side we should calculate. Now here we have to use calculate the area which is on the right side. As we know, the total area bounded by this curve with axis is always 1. On left hand side of this 0 is area 0.5, and on right hand side area is a 0.5. So the total area on right hand side of 0 is a 0.5. As we understand here, we are asked the area which has z value more than 0.5, which we can define as a 0.5, that is a half area minus area which is from 0 to 0.5. Okay, so if we know this area which is always provided, remember this, if this area is not provided in example, then you can't solve the example. As I here forgot to put the given area, which is here as in bracket given area area from z is equal to 0 to 0.5 is 0.1915. Again I missed here. Okay, now as this area is given which is 0.1915, so the shaded area which we have to calculate it is equal to 0.5 minus this given area which is a 0.915. By simplifying this as a 5803.30 85. As we have asked a percentage, so therefore the required percentage of over 100 by multiplying this area by 100. As you know, to take percentage we multiplied by 100, so 30.85. That means 30.85% of students out of total students has intelligence level over 100. In a sample of 1000 cases, the mean of certain test is a 14 and SD is a 2.5. Assuming distribution is normally, so this is an example of normal distribution in which distribution has a mean x bar is a 14 and standard deviation sigma is a 2.5. As by normal distribution we use normal variable to convert a random variable by formula z is equal to x minus x bar divided by sigma. Now we have to find we define x as we have to solve here two examples. Now in first part we have to find how many students score between 12 and 15. Now as we have given here two random variable, first is a 12, so take x1 as 12. To corresponding x1 we find z1 by taking x as a 12 in the formula of z. So 12 minus as x bar is a 14 divided by sigma is a 2.5. By calculating this we get z as a minus 2 divided by 2.5 is as a minus 0.8. So z1 is a minus 0.8. Now and x2 as a second random variable as a 15, so we evaluate z2 corresponding by taking x as a 15 in the formula. So 15 minus x bar is a 14 divided by 2.5. So this appears z2 as a 1 divided by 2.5, that is 0.4. So we get z1 and z2. Now we represent this z1 and z2 on a normal curve. For that we take normal curve. We take a graph of normal curve. So the maximum height is denoted here. The point on a curve as an average, which is a 14, and the point on axis is a 0. Now as we take first random variable as a 12, so 12 is a less than 14, so we take a 12 on left hand side of this 14 on a curve. So corresponding 12 we get normal variable z as a minus 0.8, and 15 is a second variable. I take here 15 on a curve on right hand side of 14, and corresponding 15 we evaluate the normal variable z as a 0.4. Now we have to find the number of students score between 12 to 15, which is represented by this shaded area. Okay, as a number of students getting score 12 is more than 12 on right hand side, and 15 between 15, that is on left hand side, that means this area. As this area is divided into two parts, so the area from z is equal to minus 0.8 to 0.4 is equal to area from z is equal to 0 to minus 0.8 first plus area from z is equal to 0 to 0.4. Okay, do you understand? Now as we are provided area of z is equal to 0.8, as this is symmetrical, so area from 0 to 0.8 or 0 to minus 0.8 is a 0.2821, so 0.2881, sorry, plus area from z is equal to 0.4, that is 0 to 0.4 is a 0.1554. Now adding this we get the value as 0.4435. That means this is the area which has a value 0.4435. Now as the total area is a distribution of 1000 students, so this area which is represented out of this 1000 student having score between 12 to 15. So total student which has a score between 12 to 15, multiplied this area by 1000. So multiplying this by 1000 we get 443.5. As we know the student is not in a fraction, so we take this as a 444. That means the number of students having score between 12 to 15 is a 444. Now asked how many students score above 18. Actually we have here x as 18. So corresponding x we get normal variable by taking 18 in the formula. So 18 minus 14 divided by 2.5. This is equal to actually 1.6. So z is equal to 1.6. Now putting this z as 1.6 in a graph, as we know the maximum height, the point on a curve represented mean, that is 14, and on a axis the normal variable 0. As variable is 18, which is on right hand side on of 14, so we take 18 here, corresponding having z as a 1.6. Now we have asked number of students score above 18, that means more than 18, that it represent the this shaded area. Now have to find the area which has a z more than 1.6 is equal to 0.5 minus area from z is equal to 0 to 1.6. As we have given area of 1.6 as a 0.4452, so subtract it from 0.5, so we get as the value 0.548, actually 0.0548. Now this is the area which is represent here the number of students score above 18. Now total distribution is for 1000, so total student who get score above 18 multiplied this area by 1000, so we get the value 54.8. that means we take it as an integer as a 55. So number of students score above 18 are 55.